Welcome to the 37th eBay Tech Talk. Today we have Monica Sarbu from Elastic talking on monitoring your containers with the Elastic Stack.
So hi everyone, my name is Monica Sarbu, and today I'll talk about how you can monitor your containers with the Elastic Stack. A bit about myself. So I'm working for Elastic, the company behind Elasticsearch, Kibana, Logstash, and Elasticsearch. I'm team lead in the Bits team, and today we're going to talk about how you can monitor your containers. So when you want to start monitoring your containers, probably the first thing you want to do is to fetch the logs from your container. For example, if you're running Apache as a service on your Docker container, you probably want to get the Apache logs. And then probably you want to also monitor the processes that are running on your containers and see data and see details about each process. For example, you want to see the memory, the CPU usage, and things like this of each processes. And then probably you also want to monitor the service that is running on your containers. For example, if you're running an Apache server, you want to fetch metrics from the Apache server and see details about it. And with all this information, you can have a really good view about what's happening inside your container. But probably you are also interested to see the interaction between your containers and the traffic that is flowing between your Docker containers. So we have all this information that we gather, and today I will concentrate in talking about Elasticsearch as a single way to collect all this kind of operational data in one point, and where you can use it to search the data that you are interested in across this data that you collected, and also do analytics with them. And if your number of containers grows, then you don't have to worry about it, because Elasticsearch was created from the beginning to grow with your data. Is a distributed search engine. So in this talk, I will concentrate in talking about Bits as a way to collect all kinds of operational data and ship it to Elasticsearch. Bits is part of the Elastic Stack, which consists of a suite of open source projects like Bits and Logstash on the ingest side, Elasticsearch for storing the data and do analytics there, and Kibana for visualizing the data. So the Bits family consists of a few open source projects, and we have a bit for each data type. We have file bit for collecting the log files. We have metric bit for collecting metrics periodically from different services. We have packet bit for collecting network data, and we have winlog bit for collecting Windows event logs. And you can also create your own bit based on the Bits platform, and a proof is that are already created over 30 community bits. So let's start with FileBit. So FileBit is like running tail-f on all your servers, but instead of printing the result on the screen, you send it over the wire to Elasticsearch. And it also comes with some extra powers. For example, it has support for multi-line. Think of these Java exceptions that are on multiple lines, and probably you want to group them together to see it as a single log line. JSON logs, think of this application that have support for structured logging, that are writing the logs in a JSON format. And filtering, because you don't want to ship all the log lines to Elasticsearch, and maybe you want to ship only a subset of the log lines. And for example, you are not interested in the debug messages, right? Probably you are interested only in the error messages or the warnings. So FileBit sends the log lines as they are, without parsing them. Here is an example of a log line. So the parsing, if you want to parse your log line, you need to write your own grok patterns. And there are two ways you can do that. One way is by using the ingest node, which is a plugin for Elasticsearch, and the other option is by using logstash. And in the second case, the bit needs to send the data not directly to Elasticsearch, but through logstash. And here is an example of a grok pattern for those that are not familiar with it. For example, in this case, we have our log line on top, and here you can identify that the first one is the IP, and then you have the method, and then you have the URL, and then you have the number of bytes and the duration of the get transaction. After you apply the grok pattern on your log line, you'll probably have the log line parse as in this example. So basically, this is what you will end up having in Elasticsearch. So the most important feature that FileBit has, in my opinion, is that its capability of handling back pressure. So let's see what back pressure is. So FileBit is a lightweight shipper and is able to send the log lines at a maximum speed. But you need to be careful not to overload logstash. So FileBit needs to be able to slow down when it's needed. So the way it works is that FileBit reads a bunch of log lines, then sends them to logstash, and then waits for the ACK from logstash. And only when it receives the ACK, then marks the log lines that is read as acknowledge, and then writes the offset until when it read the log lines in a registry file on disk, and then starts reading the second log line. So what this means is that FileBit is able to adapt this speed automatically depending how fast the next stage can process the data. And if the next stage is down, in this case logstash, then FileBit patiently waits, doesn't read any log lines, it doesn't buffer anything on disk, and doesn't allocate memory, it basically waits. So in this case, the log lines are not lost. Another important feature that FileBit has is that it's able to guarantee that each log line was sent at least once. But why at least once and not exactly once? Well, because it was theoretically proven that a message is not able to be sent exactly once on a losing network, and this is a conclusion of the two Byzantine generals. So in a successful case, the way it happens is that FileBit sends the log lines to logstash and then waits for the ACK. But in case the logstash is down in the same time, then FileBit doesn't know at this point if logstash already processed the log lines or didn't. So it has two options. One option will be to drop the log lines, but this will mean that FileBit is able to guarantee that each log line was sent at most once, which is something that we don't want. No one wants to lose log lines. And the second option is to resend the log lines to another logstash instance. But in this case, it might happen that we have duplicates. And the way we are planning to solve this problem in the future is that we are generating a unique ID for each log line, and we do the duplication at the index time in Elasticsearch. This is something that we didn't do yet. Okay, let's see how we can use FileBit to collect container logs. And here is a screenshot of Docker login drivers. As you can see, there are quite a few options, right? And this topic is quite discussed at the moment. And the truth is that all of these options have disadvantages. And that's why I would like to show you a few possibilities and discuss the advantages and disadvantages of each of it. Okay. Oh, so one option, can you hear me? Okay. One option is to use the Gelt driver together with Logstash, but in this case, this solution is not good because it's UDP based, so you have no delivery guarantee and no congestion control. But the advantage is that the logs are sent directly to Logstash. Another option is to use the JSON file driver from Docker together with FileBit. The advantage is that this is very easy to set up because the JSON driver is a default driver in Docker, so you don't have to configure anything extra. It's easy to add container metadata, like the label of the container, the name of the container, and the Docker logs command works out of the box. But the disadvantage is that some people think that JSON driver, when enabled, might slow down your Docker container. So another option is to use the syslog driver together with the syslog server and FileBit. The advantage of this solution is that you have good control of where your log files are going, and it also comes with the benefit that you get rotation of the log lines for free. But the disadvantage is that you need to manage an extra server, the syslog server. The metadata is serialized, so you have to deserialize it. And multi-line is very difficult to achieve because you get information from different containers mixed. Another option is to use the journald driver together with FileBit. Journald, this is the advantage is that journald is often available, and you get support for getting the container metadata like labels and the name of the container. Docker logs works, Docker logs command works, but the disadvantage is that FileBit doesn't have support for journald yet, but there is a community bit that has support for that. Another option is to use a share volume together with FileBit. So what this means is that you mount a directory from your host into your container, and you instruct your application to write the log lines in that share folder. This is easy to set up in case your application is able to rotate your log files, but it's difficult in this case to get the container metadata, like the name of the container and labels of the container. And this, if you have many containers, might not be such a big issue to see the name of the container. So in conclusion, as you can see, all the solutions that I presented that have FileBit involved are able to guarantee that each log line is sent at least once. And the other options, they have no guarantees, like, for example, the Gelt driver together with Logstash or the Fluentd driver together with Logstash.
I'm missing a little bit our solution because we simply use it from, we only want application logs in Logstash, so we don't have maybe the whole problem, but we simply use TCP appender. So we simply use logback with Logstash TCP appender and directly put the JSON files into Logstash. So we don't have the guaranteed problem of this UDP transmission, which is completely right here. But also don't write files at all because we don't even have a writable file system in the container.
Yeah, it's up to you.
This
So.
is the most easy setup currently.
If you do if log stash is down.
Yeah, then if it's long down, then we have a real problem because then we lose logs. If it's only shortly down because it's the other container, then it will retry. Yeah.
So basically, the solution, I mean, our main purpose with FileBit was to be able to guarantee that each log line was is sent at least once. That's
it's a little bit in between the both versions at the end, so from my understanding. Is this right? Or so it's half guaranteed. If the network or log set is there, then it works, and if not, okay, then we may have a problem.
yeah, I think we can discuss about this use case a bit later, and yeah, where you can tell me all the details about your setup. Okay, so coming a bit back to this one. So here it's the solution that is best for you is the one that fits better to your infrastructure. So that's why I presented for each solution the advantages and disadvantages. So you are aware of them before trying them, and then and then it's up to you to decide which one is best for you. Okay, now let's go forward and speak about metric bit. So metric bit is a new bit that it's released with 5.0, and metric bit has the way metric bit works is that it fetches periodically metrics from different services and fetches them to Elasticsearch. And we have support for a few services like the Apache, nginx, MongoDB, MySQL, PostgreSQL, Redis, Apache Zookeeper, and also you can add here support for a different service by adding a module in metric bit. Metric bit comes also with a system module that gives you information about system statics information like the CPU, memory, disk I/O, file system, load, network, per course information, per CPU cores, per process information. Okay, now let's see how we can use metric bit to collect container metrics. So there are two options. One option is to be able to get the information from your container by querying the Docker API. This is an easy solution. It's easy to set up. You don't have to do any extra configuration. With this solution, you can get information about your metadata, Docker the container metadata, like the labels and the name of the container. By querying the Docker API, you can get information like the CPU and memory usage, Docker container information, network, like in and out bytes, dropped packets, disk I/O, reads versus writes, the status of your containers, like how many containers are stopped, how many are running, and things like this. After I'm presenting this slide, I will show you a short demo where you will see in details what kind of information you can get from your Docker container. So Docker module is collecting. Docker module in metric bit was just released like 5 minutes ago with 5.1.1. And it's able to get information about your Docker containers by querying the Docker API. Another way of getting the container information is by reading the C group information directly from /proc. The advantage of this solution is that it works for all kinds of container technology you are using, not only for Docker. You don't have to use the Docker API, which might might have sometimes some security issues. But the disadvantage is that you cannot get container metadata, like labels and the name of the container. You are able to see only you are able to get only the container ID. The second solution comes part of the system module in metric bit. So if you are enabling the C group configuration option, then the process information will be enhanced with C group data. So no matter what solution you are using for gathering details about your Docker containers, you'll probably want to run metric bit in a container on your host in order to be able to monitor all the other containers that are running on that host. So an objection that I get when presenting metric bit is that Elasticsearch is not meant to be a time series database. People see Elasticsearch as a search engine, and they think that it is not so efficient for storing numbers. And this is actually not true. Elasticsearch and Lucene, the project on which Elasticsearch is based, did quite big improvements and for some time now. And this got even better with Elasticsearch 5.0, where a new storing engine was introduced based on BKD trees. So BKD trees was introduced because it has support for multiple dimensions. Think of these geo IP points where you have a longitude and a latitude. But this proved to be efficient also for one-dimension values, and those are numbers, right? So in the end, with BKD trees, it's faster to index, it's faster to query, it's more disk efficient, and it's more memory efficient. And here you have some graphs to show you the difference. So another disadvantage that Elasticsearch had before 5.0 release was that it was not able to compress the flow values. So the flow value was always represented at 4 bytes, on 4 bytes. So there are quite many compression algorithms. Think of this Gorilla paper from Facebook that describes a few of them. But they cannot be applied for Elasticsearch because of the way Lucene is storing the data. So as a workaround for Elasticsearch 5.0, there were 2 new float values types introduced. One of them is half float. That means that you store a flow value always on 2 bytes. And this has good precision for small values, but the precision degrades with the bigger the number is. The second type is scale float. What this means is that you store a flow value as an integer with a scaling factor. So, for example, if you have a scaling factor of 100, you multiply 100 with your value, with your flow value, and then the result, you store it as an integer in Elasticsearch. And when you query Elasticsearch, you divide it by 100, and this is your flow value. And this is very useful, for example, when you need to store like percentages. For example, think of the CPU usage. Yeah. And here are a few graphs that show you the difference. So why Elasticsearch for time series? Because it comes with horizontal scalability. It has a mature support for clustering. It comes with it has support for flexible aggregations, including moving averages and whole winters that are used for anomaly detection. And the most important thing, in my opinion, is that you can use a single system to also store logs and also metrics. And also comes with great UIs like Timeline UI or Grafana. And in general, it comes with a great ecosystem. think of this alerting tools or reporting tools. Now let's see PacketBit. So the way PacketBit works is that install as an agent on your servers, is listening on the traffic, and then decodes the upper layer protocols and correlates the request with the response into transaction that are pushed to Elasticsearch. So from the decoders that supports, we can note HTTP, MongoDB, MySQL, PostgreSQL, DNS, Redis, Memcache, Cassandra, and so on. And also you can add here your own decoder by adding a module in PacketBit. And for example, if the traffic that is exchanged between your services or between your containers is unknown, meaning that there is no decoder for that, you can still see a few details about your traffic. And the same case applies if the traffic is encrypted. And these details, we call them flows. And with flows, you can get a few details like the number of packets, the number of bytes exchanged, the transmissions, and things like this. I will show you in a second during the demo. So with PacketBit, you can monitor the traffic exchange between your Docker containers. All you have to do is to install PacketBit in a container on your host, and you'll be able to monitor the traffic exchange between the containers that are running on that host. Now let me show you a quick demo. So I have an Ubuntu machine on my Mac that is running FileBit, PacketBit, and MetricBit. I install them, so it's very easy to install them. You just have to go to the download page or of the bits, and then you grab the package that you are interested in. For example, I have an Ubuntu, so I got the debian package, and you install it. And then I want to run a container. I'm running on a container that is running the Redis inside. As you can see here, this is a command that I'm using. And as you can see here, I want to show you that I'm passing some labels. And with the idea that I want to show you later that you are able to monitor or to see the label that I'm passing here in Elasticsearch. Okay, so I'm running this Redis container. And now let me show. And now let's suppose we want to monitor, to get the logs from our Redis container and visualize them in Kibana. So for that, we just have to configure FileBit. So by default, the Docker container has enabled the JSON driver. So that means that will dump the log lines in a JSON format in that specific directory. So in FileBit, I just need to configure a prospector with the path to that directory where the Docker dumps the log lines. And basically, yeah, that's it. And then, yeah, here I also have configured to send the data to Elasticsearch directly. Okay, and after I start FileBit, then it will start sending the log lines without parsing them, right, to Elasticsearch in a special index pattern. So let's go to the management and see the index pattern. So I have the FileBit index pattern where I store all these log lines. So let's go to the discovery page. Select the FileBit index pattern. And now let's generate a bit of traffic. I think easier will be to restart our Docker container with Redis. So in the meantime, what I'm showing here is the 5.1.1 version that we just released like 5 minutes ago. So hopefully it works. So as you can see here, I see the log lines. And what I want to show here is that you can see basically the entire JSON, the entire log that is in a JSON format that Docker writes. And here as well, you can see the name from where the name of the log file that contained that log line and the offset. Okay, so now let's, if we want to also see, to monitor, if we want to monitor our Redis service inside the container and also the Docker container, let's configure metric bit for that. So as you can see here in metric bit, I have configured the system module that gives you information about the CPU, the load, file system, memory, network, and so on. You can configure how often to monitor the system statistics, how often to get the system statistics, and for which processes, in this case, for all the processes. In addition, I also configure here the Redis module in order to fetch information from the Redis servers. And here I specify what kind of information I want to get from the Redis servers and how often to get this information. And of course, the Redis host. Another module that I configure in metric bit is a Docker module in order to get details about the Docker containers. And for this, so this is using the Docker API, is querying the Docker API in order to get this information. As you can see, there are quite many information that we can query, that we can get. And here you can also specify how often to get this information, the host, and yeah. So basically that's it. So now if we start metric bit, it will start sending metrics to a special index pattern in Elasticsearch. So, and that index pattern is metric bit. As you can see, we get quite a lot of information. Now let's filter, for example, for the Docker-related metrics. As you can see, we also have quite many. And if I click on one, here I get information like the memory usage of the service that is running on a Docker container. So let's drill down. And for example, I want to also see the CPU usage. And here, I see the CPU usage in kernel space and so on. What is interesting is that for each metric in metric bit, you can also have this round trip time. So how long it took to. Is it better like this? Yes. Sorry. So how long it took to get a response back for that specific metric, right? Also, I would like to show you that you get information about your about all the containers that are running on your host. Let me try to do this a bit bigger. So for example, here I can see how many containers are running. In my case, it's just one. How many containers are stopped, how many containers are in total, and things like this. Now let me also show you the container information. So I can see details about my container. What I want to highlight here is that you can also see the labels that I passed when I started the Docker container. And I see that my container is up for 4 minutes. Okay, now let's see also information that we get from the Redis service. And as you can see, we get quite a lot of information about the Redis service. So I won't go through all of this, right? Okay. Also, system statistics. Quickly, I would like to show you that, for example, here we can see for each process information about this process counts daemon. So we can see the state of the container, how much memory consumed, CPU, the command line that was used to start the process, things like this. Okay, now let's go to see how we can see the traffic that is exchanged between our Docker we have only one Docker container, but you can imagine, if I have more containers, then we'll be able to see the traffic that is exchanged between them. So for that, let's configure Packetbit. And here in Packetbit, the most important configuration option is the interface on which to listen for the traffic. So by default, it's any on Linux, so we don't have to configure anything. And then for each protocol that supports, you can configure the port where to listen for that specific traffic. So we leave everything by default. So, and if we start Packetbit, then we'll be able to, then Packetbit sends all the information about the traffic to Elasticsearch in a special index, so Packetbit. Let's configure Packetbit, and and then here we'll be able to see all the traffic. So let's generate some traffic. So by generating a Redis command, as you can see, this is the info. Let me quickly look. Another info. Another info. So let's filter. Set, I think I did. Okay, and now as you can see, the time it's like 1 minute ago. When we run the command, we are able to see the set command that I just ran in on the Ubuntu machine that I have. So I can see the command, the port, the query, the return value, things like this. So just as an idea for you to see that we can also see in real time the traffic exchange between our services. Okay, now each bit is coming with a set of dashboards because this is the discovery page is nice, but sometimes you want to see or people prefer to see a chart or a graph. It's easier for you to have the big picture. So each bit is coming with, like I said, each bit is coming with a set of dashboards. And let me quickly show you. So for example, this one is a dashboard that we created to show you the CPU usage. And you can see here, we see the CPU usage per system, user space, system load, things like this. And what's nice here, you can also see basically what you can see with the talk command by running the talk command on the Linux systems. So basically the top host, no, the top host, let me show you the processes. So basically here you can see the top processes sorted by memory usage or by CPU usage that are running on my container, or on all the containers in this case. So you can see here I have CPU usage per process, CPU memory usage per process. Now let me show you another interesting dashboard. Oh, the Docker containers. So here I have 2 Docker containers that are running, and you can see one is running and 41 are stopped. And yeah, you can see some interesting graphs how the CPU usage evolves over time and things like this. And of course, these dashboards are just as a starting point for your own dashboard. So you can use this to customize or create in addition other dashboards that suit your needs. Yeah, so that's it from my side, from the demo. Now, if you guys have questions, feel free to ask me. Or Stefan, he is my colleague from the Beats team. So we are available here for you to answer all your questions. Thank you very much for listening.
Hello, Vladimir Home24. Question is, where do I run all those bits? So on each host machine in Docker Fleet?
Excuse me, where do I run?
Where do I run bits? Yeah,
okay.
The software. Is it running on each host machine, or how does it work actually? So it works probably querying Docker API, but where should I run this software?
So there are 2 options. One option is to run it on the host. So for example, if you want to monitor your Docker containers, you can run it on the host and in order to monitor the containers. Or the better option is to run it in a separate container on the host. So if we go, I have in the presentation a picture. So I have a picture for packet-bit, I think, but it's the same for all the bits, right? So you run it in a separate container, and it monitors all the other containers that are running on that host. So basically, you install a bit on each host. Yeah.
Yeah. Where do we have these YAML files you used for?
So these YAML files are the configuration.
They're for the packet-bit, right? So you have to know which container runs on which host, so that you have the right YAML file on the right host. I mean, if you have a YAML file with the Redis configuration for the beat, then you have to know on which host the Redis will run. But
yes. So it doesn't do.
You don't know where you.
So I think your question is that you need to manually configure the beat. It doesn't do auto discovery. I think this is your question, basically. So the bits at the moment, they don't do any auto discovery in the sense that you need to specify, in the case of metric bit, for example. In the case of metric bit, you need to specify from where the Redis server is available. In the case of packet bit, you basically it's a bit different story because you kind of listen for the traffic on that port. But in the future, we are planning to add support in the bits to do auto discovery by default. So you don't have to do manual configuration. So I hope I answered your question.
I have another question. So, in the continue to the one of the previous questions. So, do you know what's like overhead cost of running those, for example, metric bits, and for specific, how much CPU like will be consumed only just for monitoring and serving all those like bits, let's say? Yeah. Do you have such like estimation numbers? Yeah.
So I think the question is if I know how much the bit consumes on. So we don't have any official numbers to share with you. We did some tests a while ago when we had only packet bit, and it was 5% CPU. So it's consuming 5% of the CPU usage on that box. So it's, like I said, it's a lightweight shipper. So it's written in Go, so all the bits are written in Golang. So they are very light, so the idea is that they are not consuming a lot of resources. And as you install it on the same box with your active services, right?
Maybe, hear me? Maybe just to add to the picture, it depends on what kind of data you're going to monitor. If you're using just metric bit, yeah, we pull your service every 10 seconds, for example, if you configure it every 10 seconds. It's not much. It's just pull, JSON, push. If you do packet bit, it kind of depends on how much traffic you have in your network. The more traffic you have, the more we have to analyze. The more traffic you have, the more you have to analyze. It's the same for FileBeat. If you just have a log line every 10 minutes, FileBeat is basically idle. If you send 100K log lines per second, well, FileBeat has to read and process them and has to send to Logstash or whatever. It always depends on how much traffic you generate. Yeah.
So Telenox, you said if you generate big file, it processes and sends it. But is there any comparison with already existing solution? Asking because, for example, we are using FluentD or TD Agent, wherever, and sometimes when we have huge load, it's just, well, when we generate a lot of files, it just goes crazy and it's like 30% of CPU. Well, I do understand the reason why it does, but do you have any comparison to the competitors of FileBeat?
No, we don't have any comparison with other competitors. At least not officially. We have some internally, some benchmark that we run, but not to share with the community. It depends from the bit to bit, as Stefan was saying. So you are referring specifically to FileBeat, or?
Yeah. But there is nothing to share for.
Yeah.
Not yet.
So again, it depends. Like you're asking us questions, which are kind of hard to answer, because you have to profile yourself. You have to benchmark yourself, your infrastructure, and your how everything is supposed to work. We do not know which kind of CPU you have. We do not know how much memory you have. So we have a hard time to tell you, okay, it will take 5%. But FileBeat having back pressure, like if Logstash cannot process as many lines, FileBeat will still slow down. So this has an impact on your resource usage. You can use Go Max Procs. It's also a config option, config file option to say, okay, use at most one CPU. You can use Tasket and other tools, and you're supposed to actually. It's monitoring, and sure, monitoring might be important or is important, but your application making money for you is more important. That is, use whatever tool you have, like C groups, task set, to ensure any tool you have, FluentD, Logstash, Firebase, whatever, is in limits.
Okay, but actually I was not asking about predicting my CPU resources. I was asking exactly comparison of we have one specific node, we generate that amount of logs per second, whatever, and then using different tools to just read those logs and to ship it to whatever. So we can just read logs using FluentD, ship it to Logstash. We can use Firebase, ship it to Logstash. And I was asking exactly for the same amount of data on the same host, do you have any comparison on CPU usage of tools? No. Okay, thanks.
A question especially on Firebase. You said Firebase will recognize when Logstash has a high load and then pause a little bit. So is there an option to, let's say, kind of dynamic filtering? For example, normally he sends also debug logs, and on high load, when he sees, oh God, their Logstash cannot handle, go down to info level, for example, or something like this.
Yeah, we don't have something like this to, in real time to adjust what kind of filtering you are to do. We have only, a static filtering, let's say like this, where you can specify from the beginning which lines you are interested in and which ones are not interesting.
Maybe a new feature idea.
Yeah, that's a that's a new feature request.
What would be a suitable way to access the metrics from metrics beat if we, for example, want to use them in a CI server, so get actually knowledge back according to a job rerun, how the stage performed, or is there an API or interface?
No. So our idea was to push them to Elasticsearch. So we have a few outputs where you can send the metrics. One of them is Elasticsearch, one of them is Logstash, and they also have support for a few queuing systems like Kafka and Redis. And also you are also able to dump them in a file. No, we don't have any. Yeah, we don't have. Yeah. Any other questions? Yeah, oh, you.
How does Kibana compare to Grafana? And I mean, you didn't show the dashboard editing UI, so I assume it's some sort of Elasticsearch query underneath.
Yes, so that's a good question. It depends on the bit and the data that you want to visualize. So for example, for packet bit and file bit and Winlog bit we have, I didn't present it, but Winlog bit collects Windows event logs. It's easier to visualize the data with Kibana. With metrics, it's a different story because Kibana is not specialized for visualizing the metrics, and it doesn't have support, for example, for derivative, which is something that you usually want to visualize. So for that, we have also started Timeline, which is a plugin for Kibana, and we are in the process of working on a different plugin that is specialized for metrics. Grafana is specialized for metrics, and Kibana is a bit more general. So.
Okay,
I hope
so
I answer your question.
in the end, in a production use case, you still need to deploy Grafana to have a sensible and like more fancy UI for your metrics.
So at this moment, yes. Like I said, we have Timeline that has limited functionality. So Timeline is a plugin in Kibana. So so basically you'll be able to see so with Timeline you can do you have limited support in visualizing metrics. So for example, you have derivative. So you are able to visualize metrics in the same place with logs, for example, using Kibana. But for more advanced metric support, we don't have anything yet, but we are working on another plugin for Kibana that is specialized for doing more advanced things with metrics, which is an alternative to Grafana. Because I think, in my opinion, it will be really a pity to be able to, or to be forced to use two different UIs for two different data types. So that's why, yeah. I hope I answered your question. Yeah, so if you guys don't have any questions, you can, and if you have another question, don't free to hesitate to contact me or Stefan afterwards. You will stay for drinks as well, for food as well. So yeah, thank you very much for listening.